Okay, today I'll talk about the problem letter game. So in this game, we're given a few values for each of the numbers, for each of the letters, and we have to find the number of combinations that you can take from this dictionary so you can get the maximum number of points. And so here there are most 40,000 of these words in the dictionary, and the letters that you have will be at least 3 to almost 7 letters. So the sizes actually aren't that big, and you can just loop through all of the possible combinations of this word, and then you will be able to count how many of them have the maximum score. So I stored this dictionary inside this map. I just set all of the words that exist to true, and also I'll reading the string, which is the string that we currently have. And this string will contain the letters that we can use. So I'll sort this string first, so then we can use C++ function next permutation. And so this next permutation, you can also program this out yourself. It basically just tests all possible permutations of these letters in the string. And also this permutation, this function will prevent any overlaps, so it will only give you distinct permutations. And so we will just loop through all of the possible permutations. And for every permutation, we're gonna choose basically a starting point. And in this starting point, we will so basically we'll split this word into half. So you can get 2 of these, and then you'll be able to check if both of them exist in this dictionary. Or the other case is that you only pick something from this word. Maybe you only pick a few letters from this list of letters, or you can just pick this whole thing. And we have to check if that exists in the dictionary. And so this is the first part. We'll see what happens if we pick the whole thing, but only of this length I. So the length can be maximum up to our original string's length. And so this is good because when we are testing the maximum original length, and we get a substring from 0 and get I characters starting from 0, then we're going to get a total string if we use that on the length L. And so first, we have to make sure that this is at least length 3, because it's stated that in the dictionary all of them also have at least length 3 and at most 7. So here you will compare this. So first I will create this function to get the score, and the score is stored in this array here. I think the most troublesome part is actually typing up all of the values, and just use a normal for loop to go through each of the characters in this string and add up the values. So this is the first part. So this is what will happen if we only choose one word, because it's stated in this problem that we can choose either one word or word pairs. So this is the case when we only choose one word, and we will check, we'll get the score, and also we have to make sure that this current string exists in our dictionary. You shouldn't just use a normal access the index, because if you access this index and this doesn't exist, it's going to create a new index and give that a 0, and that's going to take up more space. So you use this count function to make sure that it doesn't exist in this dictionary. And then you compare this current score with our maximum score. If it's greater than the maximum score, we'll clear our answer set, and then we'll insert this into our answer set. And to prevent duplicates, I use the set, and also this will automatically keep everything in a sorted order, so that is what we want at the end. And otherwise, if the score is equal to our current maximum score, we'll just insert it without clearing this answer, because everything else also have the same score. And then here, this will be our length of the second, this will be the length of our second string, or our second word. So we will pick the first word, which is from 0 to I. Actually, this is from 0 and pick I characters. And then here we will start at I and pick J characters, and J will at most be J plus I will at most be equal to L, because we don't want to exceed this word limit. And we check if both of them exist in this dictionary. And if they do exist, we will first swap this so we can get the minimum here as A, and so we can get the smallest string as A and the greatest string as B, because we want the whole thing to be sorted when we insert these and print it out. And so this is basically the same thing as getting this for just one word. But here you get both scores, you add them together and compare the score with our current maximum. And still, if this score is bigger than our maximum score, we will set the maximum score to our current score and clear the answer and insert our current pair of words into this answer. And so otherwise, if the current score is equal to the maximum score, we just insert it normally. And here we'll just use this next permutation again on the strings. So this string is the amount of letters that we have. And this will just keep on going until it returns false. So when this returns false, it means that there are no more distinct permutations for this string, and so we can stop this program using this while loop. And here at the end, you just have to print out our maximum score, which we got here, and then loop through all of the answers and print it out. But you have to make sure that if it's only one word, just print the one word without printing this extra space, because the judge will not allow it. And otherwise, if we do have a second word, then we will print a space and print out the second word as well.